Let us solve problem in nuclear physics. Here problems here. A proton is bombarded on a stationary lithium nucleus. As a result of the collision, two alpha particles are produced. If the direction of motion of the alpha particles with the initial direction of motion makes an angle cos inverse of 1 by 4, then the kinetic energy of the striking proton is dash, they are asking. Now here we have to take initially proton is there. This proton is moves with a certain momentum. Certain momentum is there and the kinetic energy also there. Kinetic energy of the proton PV assume, momentum of the proton PV assume. It strikes the lithium particle. As it strikes the lithium particle and the protons are combined and two helium particles are produced. Two helium particles are produced. This is the initial motion of the proton, initial motion direction proton. Now two helium particles are produced. These two helium particles move such a way that making angle theta is equal to cos inverse of 1 by 4. Cos inverse of 1 by 4. So this alpha particle and this alpha particles are makes equal amount of angle. Now by resolving this momentum, now here alpha particle momentum we assume P dash we assume alpha particle momentum we assume P dash. This P dash if we resolve into two components, X component and Y component we are resolving. X component and Y component we are resolving. X component is P cos theta, P cos theta, P dash cos theta. Here P dash cos theta is there. And Y component is for one particle P sin theta is comes, another particle P sin theta is comes. Actually P dash sin theta, P dash sin theta, because alpha particle momentum is P dash sin theta. This Y component momentum gets cancelled. Y component momentum since opposite direction gets cancelled. And also initial momentum along x-axis only. Initial momentum is along x-axis only. So according to conservation of momentum, if we take initial momentum is momentum of proton, that is equal to final momentum is x component of the alpha particle, that is P dash cos theta, P dash cos theta. P dash cos theta, P dash cos theta. So 2 P dash cos theta we are getting. Here theta is cos inverse of 4 we are getting. Theta is cos inverse of 4 we are 1 by 4 we are getting. So that P is equal to 2P dash into 1 by 4 we are getting. 1 by 4 we are getting. So P is equal we are getting as P dash in by 2 we are getting. And we know that kinetic energy is equal to P square by 2m. Generally kinetic energy of the particle and the momentum relation is kinetic energy equal to P square by 2m we are getting. That means this equation we are going to convert into kinetic energy formula, in which means by squaring this equation we can get P square is equal to P dash square divided by 4 we are getting. Both sides we divide by half m we divide. So P square divided by m is equal to P dash square divided by here 4m and 1 by 2 is there. Now we assume m is the mass of the proton. M is the mass of the proton we assume. That means m is mass of proton we assume. Here 4m is mass of the alpha particle we are getting. That means here, now see here, this completely together is known as kinetic energy of proton we will get. This completely we will get as a kinetic energy of alpha particle. From this what we are getting means kinetic energy of proton is equal to kinetic energy of alpha particle. So kinetic energy of proton is equal to kinetic energy of alpha particle we are getting. And one more thing, as here a proton is combined into lithium and produce two alpha particles, so that the Q factor, energy some amount released will be there. That Q factor is equal to how much in the sense here two alpha particles, so 2 into 4 into binding energy per nucleon is 7.06 minus lithium particle. If you take lithium 7 particle is there, 7 into here lithium particle is given that 5.66 million electron volt. Binding energy per nucleon of the lithium particle is 5.6 is given. So 7 into 5.6 we are taking. All things are in million electron volt we are taking. So that this result how much we are getting means 17.28 million electron volt we are getting. And by taking this conservation of energy, initially kinetic energy of proton plus this Q value, energy released, this energy released is equal to twice the kinetic energy of the alpha particle, twice the kinetic energy of the alpha particle, because here one alpha particle, here one alpha particle, so that twice the kinetic energy of alpha particle we are taking. And also we calculated kinetic energy of proton equal to kinetic energy of alpha particle, so that kinetic energy of proton plus Q factor, Q value, that means when this lithium particle and the protons are combining, as reaction takes place, in that reaction energy certain amount released, that energy is known as Q factor we are telling. Here 2 into K alpha value, kinetic energy of alpha particle is kinetic energy of proton. This kinetic energy of proton if goes side that side, so kinetic energy of proton is equal to Q value we are reading. That Q is known as energy released during nuclear reaction. That energy released is how much, means 17.28 million electron volt. So energy released 17.2 million electron volt, that is equal to kinetic energy of the proton. So kinetic energy of the proton is equal to 17.28 million electron volt.